Welcome to question 7 of the 2010 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. For question 7 we have the continuous random variable x has a distribution with a probability density function given by f of x, where a in that equation is a positive constant. And for part A we're asked to find the value of a. So the first thing that we need to remember is that the area under an entire probability density function, so integrate from negative infinity to infinity of f of x dx, must equal 1. So therefore for this question we can just consider the integral between 0 and 5 for this rule here, because it's 0 elsewhere, so there's no area anywhere else. So we're going to go from 0 to 5 of ax times 5 take x dx is equal to 1. So that's the equation that we're going to solve now. And now because a is just a constant, it's not part of the variable that we're integrating with respect to, we can just go a times the integral of 0 to 5, and then we're going to expand out the x in the bracket, so we'd get 5x take x squared dx is equal to 1. And now performing the anti-differentiation, this is going to be a multiplied by, and then 5x becomes 5x squared when you add 1 to the power, and then divide by the new power. And then we're going to subtract away x, and adding 1 to the power will go to x cubed, dividing by the new power is divide by 3, and we still go between 0 and 5, and we know that that must equal 1. So if we continue our working up here, we'll have a multiplied by, and I'm just going to use a big square bracket to remember that a multiplies all of this. And to evaluate this, we use the fundamental theorem of integral calculus, which means we substitute in the upper terminal of 5. So we're going to have 5 times 5 squared divided by 2 minus 5 cubed divided by 3. And then we subtract away the lower terminal of 0 substituted into that antiderivative, which will just give 0. And we know that all of that must equal 1. So now, evaluating that out, we get a is multiplied by, and 5 times 5 squared is going to be 125 on 2. Subtract away 5 cubed, which is 125 on 3, and that is going to equal 1. And now performing that subtraction, we get a multiplied by, and 125 on 2 minus 125 divided by 3 is 125 on 6. And that must equal 1. So to get to our last step, when we're solving this, we need to get a by itself. So we're going to multiply by 6 over 125, and that will give a by itself. So therefore we get a is equal to, and then 1 times 6 over 125 is simply 6 over 125. So that is the answer for part A of this question. From the examiner's report, we can see that 50% of students got full marks for this, with a number of students making inroads into it. Some of the errors that were seen were students differentiating instead of anti-differentiating, and others had difficulty subtracting two fractions with different denominators. So if we just look at that in a little bit more detail, we can see up here where they're referring to, which is where you had 125 on 2, subtract 125 on 3. Now to perform subtraction with fractions we need a common denominator. So I'm going to multiply this fraction by 2 over 2. I'm going to multiply this fraction by 3 over 3. And that will give a common denominator of 6. So that means that this can be written as 3 times 125 is 375, all divided by 6. Subtract 125 times 2 is 250, divided by 6. And when you now subtract those, we have a common denominator, which will give 125 on 6. And that was this value here that we saw on the previous slide. Another issue that some students had was not including the dx as part of the integral. So that's this dx here, which must be included, or that's not actually a correct statement that you've made. For part B, we're asked to express the probability that x is less than 3 as a definite integral, and we're told that we do not need to evaluate that definite integral. So the probability that x is less than 3 can be written in many different ways. So we could write the integral from negative infinity to 3 of the function f of x dx and again don't forget that dx, and that could be also written as the integral just between 0 and 3 of f of x dx, because we know that when x is less than 0, the value is simply 0 anyway. And another way that we could have written that was the integral between 0 and 3 of ax bracket 5 take x dx. Any of those would have been accepted, and you just need one of them. So from the examiner's report, we can see that all of those were listed as acceptable responses. However, one response that was not acceptable was the following, and that's because the rule that's within that integral is not actually part of the overall function of f for when x is less than 0. So to turn that into a correct statement, that lower terminal needed to be 0. So overall, that question was generally well done, but a surprising number of students used 2 as their upper terminal value instead of 3, and that's because they were treating the distribution to be discrete integers, whereas we know for a continuous random variable we can actually include 3 in that terminal, even though the probability was asked for being less than 3. A number of students continued to work out the numerical value incorrectly, and thus lost a mark that they would have been awarded for simply setting up the correct definite integral. So it was really important to read the instructions of that question, as it did state explicitly not to actually find the numeric value.